Alright, if you've been following along, this is the second video for this sheet. We're at example number 3 here, and we have a ball thrown straight up, and it leaves the player's hand with a velocity of 30 meters per second up, and it accelerates at minus 10 meters per second squared as it rises to its maximum height. Of course, that minus 10 is just a bit of a friendlier number rather than the 9.8 close to the surface of the Earth. Well, let's make a velocity time graph of what that would look like. So we would start at 30. Now clearly what it's going to look like is, let's say this is the ground, and here's our player, and they throw the ball straight up and then it comes down again. At the beginning it's going to be going upwards at 30 meters per second, and then at its highest point here, that's when the velocity would be 0. And then as the ball accelerates downwards, it's going to come back to the person again. And so that's going to be at the end. So just a couple of things here. This is a shape for the velocity time graph we see a lot because we throw balls, well, we pretend to throw balls in the air a lot in this class. So it's going to go start at 30. Here it's hitting a 0 velocity, and there that's what it would be hitting, minus 30 meters per second. The slope of this line, the slope of this would be negative 10. So our first part is, what is the time to reach the maximum height? And I even give you a nice hint in this question. It says, at maximum height, the velocity will be 0. So this is the part, and this is the moment where it hits the maximum height. So what would this time be? How could we figure that out? Well, for some of you, it's pretty straightforward. You can say, well, if it's starting at 30 meters per second, and what is acceleration? It's the rate at which time changes, or it's the rate at which velocity is changing. If it's going down 10 meters per second every second, it's going to take 3 seconds. This is pretty straightforward. It's almost one of those, like, it's too obvious to think about. But let's say the numbers weren't quite so friendly. Yeah, again, you could say, well, acceleration on this is slope. Slope is equal to rise over run. Right, so this is my acceleration. So minus 10 is equal to, now from here to here, how much is it going to rise? It's going to rise minus 30. And the run part, that's how much the time is changing. This from here to here is the change in time. Right, from here to here on this triangle, this is the change in velocity. So this would be delta t. And now we'd be solving for delta t. Sometimes when the unknown's in the denominator, it's a bit more tough. So what we could do is, and I kind of do this as a mental kind of a quick step, is we can switch those two. So I could quickly write delta t is equal to minus 30 divided by minus 10, which is equal to 3 seconds. But so much easier just to think, oh, if it's changing by minus 10 every time, if it's dropping by 10 meters per second every second, it's got to be 3 seconds. So that's the first part. B, what's the maximum height reached? So the maximum height, we're only going to think about this interval of time. We're not even going to be thinking about this whole interval of time. When I drew this, I was thinking about the ball going up and the ball coming down again. So the interval of time that we want to consider would only be between 0 and 3 seconds. So the only area that we want is the area of that triangle. So the maximum height is a vertical displacement. And that's going to be this area, and it's 1/2 times the base times the height. The base is 3 seconds, and the height is 30 meters per second. So my answer there would be 45 meters. It takes a little to get used to thinking in this question. This is positive, right? Up is positive. So when I'm saying, delta D, it's not a horizontal displacement, it's a vertical displacement. Later on, when we're talking about projectiles, we're going to be dividing up between X direction and Y direction. But right now, we'll just say, we mean up is positive, so how far does it move? It went 45 meters in the positive direction, and that's up. I would actually like you to try example 4 as your turn. Give it a shot. I'll just pause for a minute, and then instead of just revealing, I'll slowly work through it. So I'll give you a chance to see if you can get it on your own. Okay, in this question, a driver hits an icy section on the road. If the car moves 60 meters in 25 seconds before coming to a stop, find the car's initial velocity. So clearly they had some positive initial velocity and then they slowed down to a stop. So here's the initial velocity. So there's velocity, there's time, and at the end of it they had 0. They must have gone at a constant negative acceleration. In other words, this has to be a straight line because Mr. Spizer's being nice to you like I just promised, and that in all these questions we'll have constant acceleration. So this is a straight line. So as the car was sliding along the ice, at least the person felt happy that it was a constant negative acceleration as they were sliding across. But we need to know, what is this velocity up there? We know that this is 25 seconds. And the other information that we know is that this piece in here is 60 meters. So this area is equal to 60 meters. So let's do that. We can say this area here, delta D, is equal to the area, which is equal to 1/2 times the base, which is, here I'll go like this, 60 meters is equal to 1/2 times the base, which is 25 seconds, times the height, which is some unknown amount of meters per second. So maybe I'll get rid of this unit here. I'll just say 25 times the change in the velocity. So we don't know exactly what this is, but we want to solve for this. This is how much the velocity changed by. Okay, well, 1/2 times, well, you know what, the easiest thing, if I'm going to do this in my head, is I would multiply both sides by 2 to get rid of the fraction. So I'll say 120 is equal to 25 times how much the velocity changed. Now I'll divide both sides by 25, and 120 divided by 25, 4 and 20 over 25, so 4.8. Now because the velocity started at 0, then the final velocity, oh actually this is the initial velocity, isn't it? The initial velocity was equal to 4.8 meters per second. So in other words, because this side of the triangle is 4.8 and we started at 0, the top of this must be 4.8. Okay, cool, and there's your answer. Hope you did all right. So in class we have a worksheet of similar style of questions to work on, and I look forward to seeing you then.